All right, on homework 4.3, we're dealing with differential equations. The first one I'm going to do is number 2. It gives you the second derivative and asks you for the original function. So, to figure out what the original function was, we first need to find what the first derivative was, and the way we find that is by doing the integral of the second derivative. So the integral of the second derivative is the first derivative. It's the antiderivative of it. And the integral of 4 is 4x, because the derivative of 4x is 4. Here we do the power rule. It's going to be x squared. The power goes up by 1, and we divide by 2. We've got the power rule. We're going to have x to the 4th. We divide by 4. The integral of e to the x is e to the x. And then we get plus c. So the original derivative was this thing plus a constant, because when we do the derivative of this, that gives us the correct second derivative. Now, before we move on, we need to figure out what c is. We're finding the particular solution for the derivative, and what we're going to use is the information they give us here. They say the derivative when x is 0 is 3. So that means when x is 0, the derivative is 3. Now, notice I put zeros here because 4 times 0 is 0, 3 times 0 is 0, 10 times 0 is 0. E to the 0 is not 0. E to the 0 is 1. Anything to the 0 power is 1. So c equals 2. So that tells me that the derivative was 4x minus 3x squared minus 10x to the 4th plus e to the x plus 2. This now fits both the things. When I take the derivative of this, it gives me the second derivative, and when I plug in 0, the derivative will be 3. All right, now I need to find the original function. The original function is the integral of the derivative. So this is going to be x squared, the power goes up by 1, and we divide by 2. This is going to be x cubed, the power goes up by 1, and we divide by 3. That'll be 1, I don't need to put the 1 there. This will be x to the 5th, and we divide by 5. 10 divided by 5 is 2. And the integral of e to the x is e to the x, because the derivative of e to the x is e to the x, plus 2x. The derivative of 2x is 2, plus another c. And this time, we have that when x is 0, the original function is equal to 0. When x is 0, the y value is 0. So f of 0 is 0, 0, 0, 1, 0 plus c, and this needs to equal 5. So c is 4. Excuse me. So that means the original function, f of x, was all of this, except we're going to plug in 4 here for c. And I ran out of room, but you can do that. All right. In the next set, a few things. I'll do a couple of these and make sure we understand what's going on here. Part A, we have a product. It's this times this. There is no product rule for integrals, and so we can't leave it as a product. What we need to do is we need to rewrite it as something we could do the integral of. So we're going to multiply this out. We're going to distribute and get 6 square root of x plus 5x square root of x. That's what we're doing the integral of. I'm sorry, guys. So we need to rewrite this as a power rule thing. This is 6x to the 1/2. This is x to the 1 times x to the 1/2. And remember that when you're multiplying, you add exponents. 1 plus 1/2 is 3/2. And so this is what we're doing the integral of. And you can do the power rule on your own from there, I think. On B, the only tricky thing is that the integral of 3 over t is not 3t to the negative 1. You can't add 1 and divide by 0. This is not a power rule 1. What we should recognize here is this is 3 times 1 over t, and the derivative that gives us 1 over t is natural log. Specifically, the integral of this is 3 natural log of the absolute value of t, which is a little bit weird, but it's what it is. Let's see. Any other ones here that are tricky? Yes, this one you should recognize. It's just a derivative you should have memorized. There's something that when you take the derivative, you get this, and if you don't recognize it, you need to go back and look at your first semester notes of all the derivatives you're supposed to have memorized and rememorize all of them, not just this one. This one you need to rewrite. This is, again, a quotient, so you can't do a quotient. This is the integral of 1 over sine is cosecant, and this is cosecant squared of t. Now, since we're doing the integral of cosecant squared, we should recognize that the derivative of cotangent is negative cosecant squared. So the integral of cosecant squared is going to be cotangent, except this derivative would be negative cosecant squared, so we need a negative here. That way it'll be negative cosecant squared, and it'll give us the right derivative plus c. All right, I'm going to grab a Kleenex real quick. This is not working for me. All right, let's see. Let's look at number 5. It gives you the velocity. It says the velocity is v of t equals 3t squared minus sine of t plus 4. First, it asks for the acceleration. Well, the acceleration is the derivative of velocity. So a of t equals 6t minus cosine of t plus 0. That goes away. And you just plug in pi, right? You're evaluating it. But then it asks for the position of the particle. And the position is the integral of velocity because the derivative of position is velocity. So the position is going to be the integral of velocity. And so when we do the integral, it's going to be raise to the power by 1, divide by the new power. The integral of sine is not cosine. The derivative of cosine will give you negative sine, and so we need to change the sign of this, because when we take the derivative of cosine, we'll get negative sine. And we get 4t here plus c, and it tells us that the position at 0 is 6. So 0 plus cosine of 0 plus 0 plus c equals 6. Cosine of 0 is 1, and so that means c is 5. So the position, s of t, is equal to t cubed plus cosine of t plus 4t, and the c value was 5. So that's what we should get there. All right. Any tricky ones in the back? Yes. Some new ones. Let's look at 7. 7, this doesn't look like anything we know, and we can't simplify it as it is. The trick you're going to need to use here is that you need to use your Pythagorean identity using sine squared plus cosine squared equals 1 to rearrange to get 1 minus sine squared equals cosine squared, and replace 1 minus sine squared with cosine squared. Whenever you see 1 minus sine squared or 1 minus cosine squared, you should be aware that you can change that out with the other one. And then from there, it's just like a homework problem we had the other night. I think you should be able to do the rest of these on your own. I'll do number 10, just in case we're struggling. This video is getting a little bit long. So it says the derivative is x cubed, and the line y equals x plus y equals 0 is tangent to the graph of x. So let's see. So we're supposed to find the original function. So f of x is going to be x to the 4th divided by 4 plus c. Our trick is that we have to be able to find what c is. And so we have to use this other piece of information to figure out what c is. I'm going to rewrite this as y equals negative x. I move the x to the other side. And what this tells me is that this is the tangent line. The slope of the tangent line needs to be negative 1. And the slope of the tangent line is the derivative. F prime of x has to be negative 1 at the point where it's tangent. And so I'm going to solve and say x cubed has to be negative 1. So x is negative 1. Take the cube root of both sides. So at x is negative 1, this line will be tangent. And so now I can use this value right here and say, well, y equals negative 1, y equals 1, and that gets me an x and a y value. of the point of the tangent line. And since this is a point of the tangent line where it's tangent to this graph, what I can do is I can plug in x is -1 and y is 1 to solve for c. So 1 equals 1/4 plus c, c equals 3/4, and so the equation is y equals, or f of x equals 1/4 x to the 4th plus 3/4. So you have to use your knowledge of tangent lines. You should immediately be able to say that the slope of the tangent line is the derivative, and then the y value of the tangent line is also the y value of the function, because that's the way a tangent line works, is the tangent line hits the function at that point. All right, hope that helps.